Okay, so for this one, we're going to have 2x minus 6 over 7 equals 8, or 2x minus 6 over 7 equals negative 8. And then we can cross multiply, add 6, 62, so x is 31. Or 2x minus 6 equals negative 56, plus 6 is negative 50, so x is negative 25. That's for A. For B, we've got 2x minus 6 over 7 is less than or equal to 8, or, and 2x minus 6 over 7 is greater than or equal to negative 8. So now we, here it's fine to cross multiply because you're multiplying by 7, which doesn't change the inequality. Adding 6 is 62, so x is less than or equal to 31. Same thing here, multiply by 7 is negative 56. Add 6, and then divide by 2. So for this one, we'll have x squared minus 9 is 7, or x squared minus 9 is negative 7. So x squared is going to be 16, which means plus or minus 4. And here, x squared is 2, so x is plus or minus root 2. Just up here, you can write this in a compound inequality because it's in between negative 25 and 31. Okay, so for this one, we want to find the zeros. So 5 minus 3x equals 0. So x is 5 over 3. And for the next one, it's x equals negative 1. So we need to check in those intervals, okay? So we're going to have less than negative 1, in between negative 1 and 5/3, and after 5/3. So if we get a picture of what this graph is looking like, the x plus 1 is looking like this because we have y-intercept 1 and gradient 1. And the 5 minus 3x is going to be 5 up here, and then minus 3 is the gradient, so something like this where it intercepts at 5/3. Okay, so we have several intervals. So we've got at 1, before negative 1, and we have in between negative 1 and 5/3, and we have after 5/3. Okay, so if we have before 1, you can see that the x plus 1 is less than 0, so negative x plus 1. And we have the 5 minus 3x is above the y-axis, so that's just going to be the positive. So we have 5 minus 3x is less than or equal to negative x minus 1. So we're going to have 2x on this side and 6 on this side. So x is greater than or equal to 3 for that one when we divide by 2. All right, in between negative 1 and 5/3, they're both above the x-axis. So we're going to have 5 minus 3x is less than x plus 1, both positive. So we're going to have 4x and 4, so x is greater than or equal to 1. And, after 5/3, we are going to have that the 5 minus 3x is less than, and the x plus 1 is greater. Okay, so we're going to have negative 5 plus 3x less than x plus 1. And we're going to have 2x and 6. So x is less than or equal to 3. All right, so what we were talking about in class, because x is less than negative 1, but this is saying x is greater than 3, this one is rejected. Okay, so this one's okay because x is greater than or equal to 1. And this one is saying x is less than or equal to 3, but greater than 5/3. Okay, that's fine. So we have x is greater than 1. And x is less than 3, so that's our intersection between 1 and 3. The other way to do this, which I didn't get a chance to, is graphing these absolute value. So if I graph these, so here's the 5 and here's the 5/3. So that's the 5 minus 3x. When I put absolute value on it, that makes all the y's positive. So this bit of the graph here below the x-axis flips above. Okay? And this bit goes away. All right? So that just keeps going. Then if we have the x plus 1, which is this one, oops, like that, this bit that's below flips up. Okay? So this bit goes away. And this is at negative 1. So we want to know when the 5 minus 3x, the blue line, is less than the black line. And that's happening here. So we need both of those intersections. And how you find those intersections out is you do 5 minus 3x equal to x plus 1. And 5 minus 3x, one of them has to be negative. And I'll just make it this side. Okay? So here we're going to have 4x equals 4. So x is 1. That's this intersection. And if we do this one, 5 minus 3x equals negative x minus 1. So we're going to have 2x equals 6, x equals 3. So this is 3. So in between 1 and 3. Okay, this one I'm going to do two different ways. One with the graphing calculator, which is the easiest, and the other one with squaring both sides. So, all right, if we go to a graph and we get rid of everything, and I'm going to go to just standard view. Okay, so if we go tab, we can put in the first inequality, and it's in here. And you need to put in x minus 2. And then tab and same thing. And we need 2x plus 1. 2x plus 1. All right, so we want to know when the blue line is greater than the red line. Okay, that's only happening here. That's it. Every time else, the red line is above the blue line. All right, so we need to find those two intersections. So analyze graph, intersection here. So from negative 3 to 1/3. So when we use the squaring both sides method, as long as both sides are non-negative, which absolute value by definition. So the equality will hold. So when we square both sides, we're going to have x squared minus 4x plus 4 greater than 4x squared plus 4x plus 1. and then we just solve as we know. So 3x squared plus 8x minus 3, and then we can factor, and we need a positive 8, so we need plus 9 minus 1. So this is back to a couple lessons ago. So we have x is, the zeros are x is 1/3, x is negative 3. So can be both of those. Check, or actually it's quadratic, so we don't really have to check. So it's like this, and it's less than 0 in between negative 1/3 and 1/3. Okay, so I've already got it in the graphing calculator. We just need to find the intersections here. And we want the blue line to be less than the red line, which is happening before 3 and after 27. The other way we can do it is squaring both sides. So on top, we're going to have x squared plus 18x plus 81 over x squared minus 18x plus 81 less than or equal to 4. And we can cross multiply. And get it equal to 0, so 3x squared minus 90x, and we need 324 minus 81, which is 243, and we can factor, oh actually 3 can come out, so x squared minus 30 plus 81, and we can factor now 27 and 3, so minus 27 minus 3, so if we have 327, it's quadratic like this, we want it greater than 0, that's before 3 or after 27. So if we do this another way, I just want you guys to have all the ways. We can put this in between. We can take away absolute values because I'm putting it in between negative 2 and 2. So I'm going to deal with it separately. X plus 9 over x minus 9. And so we can do and, because it's an intersection, x minus 9 less than or equal to 2. Okay, so we have rational, so we need to get this equal to 0, or 0 on one side, so we're going to add 2. So x plus 9 over x minus 9 plus 2, which is going to be x plus 9 plus 2x minus 18 when we get the same denominator. So we're going to have 3x minus 9 over x minus 9. So our zeros here are 3 and 9. And on a number line, it can't be 9 because that's the denominator, and it can be 3. So we need to check what's going on before, during, and after. So at 2, we're going to have negative over negative, so that's positive. 4, it's positive over negative. And 10, it's positive. So this is greater than 0 before 3 or after 9. Okay, so we have, for this one, x plus 9 over x minus 9 minus 2, and then getting the same denominator, we're going to have minus 2 times x minus 9 over x minus 9. So we're going to have x minus 2x, which is negative x, and 9 plus 9, so 18 over that. So our two zeros are at 9 which it can't be equal to, and 18, which it can be equal to. So we'll test 0, 10, and 19. So this is going to be negative, this is going to be positive, and this is going to be negative. So we've got before 9 or after 18. So now we have to find the intersection of these things. So on a number line, we've got 3. So it needs to be less than 3. We've got 9 and we've got 18. So for 9, we've got x is greater than 9. We've got x is less than 9. And we have x is greater than or equal to 18. So these are our intersections here. So x is less than or equal to 3, or x is greater than or equal to 18, which should be 27. 1 second. Where did I mess up? Oh, it's 9 plus 18. So this should be 27. So yeah, this should be 27. So this should be 27. So this should be 27. Okay. Okay, 14. Without graphing calculator. So we can square both sides or do it like I just did it in the previous one. So we're going to have x squared plus 2x plus 1 over x squared greater than or equal to 4. And since we're multiplying by x squared, it doesn't change the inequality. And then we need to get this side 0. So we've got 3x squared minus 2x minus 1. So we've got 3x, 1, x, and 1. And we need a negative 2, positive 1. So zeros are negative 1/3 and 1 on the number line. And it's quadratic up, and we want that less than 0, so it's in between negative 1/3 and 1. So this one you can't do, well, the squaring both sides is much longer because you've got 2 separate absolute values. So we have to do it the longer way. So you have to find when the absolute value is 0. So that's at 5 and 10, and you have to check within the intervals. So we have less than 5, in between 5 and 10, and greater than 10. So if we do a sketch of this, we've got negative 5 and then positive x minus 5. Okay, so yeah, so this is negative 5 and this is 5. And if we do the x minus 10, we're going to have, so like here, negative 10 and gradient 10. So it's like this. Okay. Sorry, gradient 1. Okay, so our intervals are before 5, in between 5 and 10, and after 10. Okay, so you can see that before 5, they're both negative. So we're going to have negative x minus 5 minus negative x minus 10 less than or equal to 7. So if we solve this, negative x plus 5, a negative x plus x, and then plus 10 minus 10 less than or equal to 7. So we get -5 is less than or equal to 7, which is true. Okay, so in between 5 and 10, we have that the x minus 5 is positive, but the x minus 10 is negative. So we've got positive x minus 5 and then a negative x minus 10. So we've got 2x, x plus x, and -5 minus 10, which is -15. And then add 15, so 22. So x is less than or equal to 11. And then greater than 10, both are above. So we've got x minus 5 minus x minus 10 less than or equal to 7. So the x's cancel, and we've got -15 is less than or equal to 7, which is also true. So interpreting this, we've got when x is less than 5, it's true. Okay, it works. For all x's less than 5, this thing is less than 7. Same thing with x greater than 10, that thing is less than 7 or equal to 7. For 5 through 10, we get that x has to be less than or equal to 11, which works for 5 through 10. So this is going to be that x is all real numbers. It works for all x's. This thing is always less than or equal to 7. And I'll take a picture of the graph so you can see. So there you can see that our graph here is always less than 7.